Alright, so this topic we will be talking about similar triangles heavily. What does it mean by similar? First thing which we have to realize is that they may be in different size. Different sizes. But have the same shape. Alright, so that's basically what it means by similar figures. We mainly talked about similar triangles, but this idea is true for any other polygons. Corresponding basically means matching. So if I were to just give you one example, I'll say this angle is congruent to this angle. And then I'll say this double marked is same as this one. And then dot, here, dotted angle is same as this dotted angle. Now, then one thing that which we have to realize here is, what if I were to go for this line segment? Which out of the three sides from the smaller triangle is corresponding to this given side? Notice that this side here is between dot and double marked. So where's dot? Here. Double marked here. So then this side will be corresponding to this side because they are in the relatively same location. And that's what it means by corresponding. Now, mid-segment. Mid-segment is in a triangle. You get the midpoint. Let us say midpoint is around here. And the midpoint is around here, let us say. When you connect the midpoint, this line segment is called mid-segment. What do you realize about mid-segment? It creates the two similar triangles. One small one on top and one big one. Those are two similar triangles. Another thing is mid-segment is parallel to its base. And the ratio is, if this one is x, this one will be 2x. 2-to-1 ratio. So that's another thing there which we have to realize about mid-segment. Now, if two triangles are similar, their corresponding angles are congruent at all times. Their corresponding sides are in proportion. And we will be using them very soon. Oops. All right. So if two triangles are similar, now let us assume that the ratio of the corresponding sides are A to B. We're going to assume that they are A to B. Or we can write it as A over B. Either way is fine. Then their perimeter will still be A to B ratio. Or we can write it as A over B. Their altitude will still be A to B ratio because they are all talking about some sort of size. But the area will be in ratio of A squared to B squared. Or we can write it as A squared to B squared. Once again, notice that only area has different ratio, square of the whatever is given. On the other hand, let me just add one more thing here in this case. How about angles. Angles are, in fact, interesting thing is that they are not in A to B ratio, but they are 1 to 1. Why? Because angles has to be congruent. So that's one thing that which we have to realize also. All right, then let's move on to the next question. A triangle has sides whose lengths are 5, 12, and 13 here. That's given. The similar triangle could have sides with length of. So then all three sides has to be in this ratio, 5, 12, 13. When you look around 3, 4, 5, is that the same ratio as 5, 12, 13? Not quite. In fact, only thing that would be same ratio would have been this one, choice number 4. Why? If you double 5, then you get 10. If you double 12, then you get 24. If you double 13, you get 26. So therefore, choice 4 becomes our answer because we doubled everything. If you had to write up the proportion, it would have been something like this, 5 over 10. Is that equal to 12 over 24? Yes, it is. They're all halves. And 13 over 26. See? That's why the correct answer would be choice 4. Now here, you can see that this is similar triangles because they're parallel. That means this angle is congruent to that angle. Why? Corresponding angles. And angle A here can be reflexive. So now, then one thing which we get to realize is this. The corresponding sides are in proportion. So this would have been 6. And what do you think this one would have been? That would have been total 6 plus 15, which is 21. Now, so 6 corresponds to 21. How about the other side? We have 4 corresponds to what's the whole thing? I don't know. Let me call this one as x. Then what we could have done is whole thing would have been 4 plus x. Because if only bottom portion is x, as you can see here, then 4 has to be added on to x to get the whole line segment. So therefore, the equation which we can write up is 4 plus x. Then obviously we can cross multiply them. 4 times 21 becomes a 84. Is equal to 24 because 6 times 4 plus 6x. Subtracting 24, then we end up getting 60 is equal to 6x, and x equals 10. What is the length of AB? AB would have been equal to 10 here. All right. Now, this is the right triangle altitude theorem, or we have right triangle within a right triangle. So there are many different ways of approaching this one. One way is to find the similar triangles and then write up the proportion. Now, the method that I'll be using, in fact, is called toothpaste and smiley face. So, for example, one relationship which we have to know is in the triangle. If this is right triangle here, if I call this one as A, and then this is B1, and then B2, and then C, and then height, A square would have been equal to same side line segment, which is B1, times the entire thing, B1 plus B2. And then C square is equal to same side line segment, which means B2 times B1 plus B2. Now, how do you memorize this one? I use the something called toothpaste. It's kind of silly, but toothpaste and then smiley face. Here, what I have done is, first one, A2 means this side times the same side. Oops. Line segment is equal to B1, which is same side line segment, in times the whole thing. And this one looks like a toothpaste. Yeah, I know it's very silly, but how is it toothpaste? It will be something like this. Here, and then here, toothpaste and toothbrush. And then how about C square equals B2 times, okay, that in the C square would have been This would have been C, and then same side line segment here. That's C squared, C times C. B2 is the same side line segment times the whole thing. So once again, we can go for toothpaste, toothbrush, yay. So that's how you can do it. Now, last one is the H square. Last relationship is H squared is equal to B1 times B2. Oops. How do you get that? Then it will be H squared, that means same side, the vertical line segment. H squared, B1 is on the left side, B2 is on the other side. How is this smiley face? How about that? Hey, smiley face. So now, how are we going to use it? Let us try to look at A. To find A, I'm going to use the first one right over here. So notice that A squared see this side square is equal to the same side line segment, which will be 8 times the whole thing, which is 6 plus 64. That's right, that's 72. So that's basically what we end up getting. Now, then A squared is 576, I believe. Now, then A, in fact, becomes 24. I believe 24 squared is 576. Check it to see if it's right. All right, now, next one would have been the other way, the B squared, or H. Let's go for the H squared. How do you go for H squared? H squared, we can use the smiley face here. That means H squared is equal to 8 times 64. Okay, so then H squared, H squared would have been 512. So H would have been equal to square root of 512. Now, square root of 512 is in fact square root of 2 times square root of 256, I believe. But square root of 256 is equal to 16, so this ends up being 16 square root of 2. So that's how we can do H squared, or H. How about B? To do B, we're going to use the C squared, the same thing here. So B squared is equal to 64, same side line segment. See, B is on the right side and then 64 is on the right side, times the whole thing, which would have been 72. Then if you have to calculate this one, I believe B becomes 48 radical 2. I believe that's what we end up getting. Yeah. So that becomes our final answer. Alright, let's move on to the next one. The base of an isosceles triangle is 5 and its perimeter is 11. Alright, so then let's look at it. So we have, so we're going to assume that this is 5. But the other two sides we have no idea, so we have x and x. But perimeter is equal to 11. The base of similar isosceles triangle has 10. So it's going to be a bigger one. And then this one would have been 10. And obviously it's a double, so we're going to have 2x and 2x. What is the perimeter of the larger triangle? You see, notice that 5 became 10. What happened? It doubled, multiplied by 2. Then even the perimeter has to be doubled. So perimeter, our new perimeter should be 22. Because perimeter is in the same ratio as the length of the side. And we talked about that earlier here on this slide. Alright, let's look at number 5 here. The length of the sides of two similar rectangular billboards are in the ratio of 5 to 4. 250 square feet of the materials are needed to cover larger. So one of them is this way, and then the other one is this way. Let us assume. So the ratio is what? 5 to 4 of the size. So 5A and then 4A, or one way or the other, 5 to 4. But the 250 square feet of the material is needed to cover the larger one. So even though side is 5 to 4, how about the area? If you remember what we talked about earlier, area is a square of this ratio, so we get 5 squared, which is 25 to 16. That's what we end up getting. But for the bigger one, what we actually end up using was 250, as you can see from the question. Then how much of the square, how much of area do we need for the smaller one? So this one becomes 250. And how much is smaller one? I have no idea. So let's try to set it up. Then expression which we can set it up is 25 over 16, that ratio, because these are square of 5 and 4 because we're talking about the area, is equal to 250 over x. Yes, some of you guys might have noticed that we just have to multiply the first ratio by 10, then we get top and bottom. By 10 we get x, or we can just cross multiply them. 25x is equal to 16 times 250, and then when you divide by 25, x will be equal to 160, one way or the other. So our answer will be 160 square feet. That becomes our answer. Alright, so let's look at the next one. If AC is 10, and then AT is equal to AT is equal to 18, and CT is equal to 22. What is the perimeter of triangle DOG, which is the one inside? Since this one is 22, the DO would have been 11 because half of that. Since AC is equal to 10, this would have been 5, half of the half of the length. That's what mid-segments are all about. So this AT is equal to 18, then DG is equal to 9. So all we have to do is we just have to add up those 3 line segments. So 9 plus 11 plus 5. That will be the perimeter. Here we get 25. Alright, that's it. And I'll see you later. Bye.